Okay, this is lesson 11.3, and today we'll be solving radical equations. Okay, so radical equations, a radical equation is just an equation that has a variable inside a radicand, or under the radical symbol. It's part of the radicand. So when you're trying to solve a radical equation, this is what you want to do. You need to get the radical alone first, the whole radical alone, and then square both sides. Okay, an important little thing to note is when x is greater than or equal to 0, if you take the square root of x and you square it, you get x. Okay, that works when x is greater than or equal to 0. You take the square root of x and square it, you're going to get x. So, I'm going to solve a couple equations. Here's the first one. Square root of x minus 5 equals 4. So the first thing I'm going to do is get my radicand, or this whole radical, get that alone. Okay, so to do that, I do just like I would a normal linear equation. I'm going to add 5 to both sides. When I add 5 to both sides, I get square root of x equals 9. Okay, and then to solve this, I'm going to square both sides. So if x is greater than or equal to 0, the square root of x squared just equals x. And 9 squared equals 81. Okay, sometimes we get some weird things happening here, so I do want to check my answer and see if x really is 81. So I'd plug it in. I'd see, is the square root of 81 minus 5 really equal to 4? Well, square root of 81 is 9. 9 minus 5 does equal 4, so it checked out. So my answer in this case was x equals 81. Okay, I want you to look at the second problem, and I want you to focus on how this is different from the first one. Okay, this time it says absolute, or it's not absolute, sorry, square root of x minus 5 equals 4. Okay, so see if you can spot the difference. Okay, the difference this time is that the minus 5 is under the radical. So this time I already have my variable, or my radical. I have my radical all alone. So the first thing I'm going to do is square both sides. Okay, so I'm going to square this. Okay, so square root of x minus 5 squared, that's going to be x minus 5. 4 squared is 16. Okay, and then I've got x minus 5 equals 16. I'm going to add 5 to both sides, and I get x equals 21. Okay, again, since I told you, hey, sometimes some weird things go on, let's check that. So square root of 16 minus 5, I want to know if that's really 4. I'm sorry, 16 is not the answer I got. 21 is what I got. So square root of 21 minus 5. 21 minus 5 is 16. Square root of 16 is 4. So it looked like it checked out, and I'm happy. X does equal 21. Okay, so key difference, when the minus 5 is under the radical and you already have the radical alone, go ahead and square first. When it's not, make sure you get everything else away first. Okay, here's a real world problem. On a roller coaster ride, your speed in a loop depends on the height of the hill you have just come down and the radius of the loop in feet. So here's an equation. V equals 8, Okay, V equals 8 times the square root of h minus 2r. That gives the velocity v in feet per second of a car at the top of the loop, so when it's up here. Okay, the loop on a roller coaster ride has a radius of 18 feet. So right here, this is 18 feet. Your car has a velocity of 120 feet per second at the top of the loop. And I want to know, or at the top of the loop, how high is the hill of the loop that you have just come down before going into the loop? So we're going to go ahead and use this equation. So V is my velocity, I know that, it's 120, equals 8 times the square root of h, we don't know h, that's what we're trying to find, minus 2 times r, and I know that r is 18. Okay, so I'm going to solve this equation as much as I can. I would probably go ahead and simplify this under the radical first. So it's going to be h minus 36 times 8 equals 120. Okay, the radical is not alone, so you want to get it alone by dividing both sides by 8. Okay, so those cancel. 120 divided by 8 is 15. So 15 equals the square root of h minus 36. Now you have the radical alone, and you can square both sides. Okay, so I'm getting 225 equals h minus 36. Then I'd add 36 to both sides. I should get 261 equals h. So h tells me the height in feet, yep, in feet of it, so it's going to be 261 feet tall is the hill that you just came down. Okay, so seems like a pretty good, decent roller coaster ride. All right. Okay, I think we've seen these before a couple times in our math career. Extraneous solutions. Extraneous solution is an apparent solution that does not make the original equation true. So you have done every single step of work right, but you get an answer, and when you plug it back into the equation, something's fishy. It's not checking out. So because of this, that's why I'm encouraging you to always check. Here's going to be an example of this. Okay, so we're going to solve the square root of 3x minus 4 equals the square root of 2x plus 3. So this time, I have a radical on both sides, but thankfully they're already both alone, which is nice. I'm allowed to square both sides here. Okay, when I square the square root 3x minus 4 squared, I just get 3x minus 4. When I square here, 2x plus 3 squared, I just get 2x plus 3. Okay, I'm going to go ahead and solve this equation. So, add 4 to both sides, and I would also probably subtract 2x from both sides. Okay, here we get x equals 7, and then I'm going to go ahead and try that. So I think x equals 7. So then I have 3 times 7 minus 4 equals, and the square root of that, equals the square root of 2x plus 3, and that's going to be 7 again. I'm going to substitute that in. So 3 times 7 is 21, minus 4 is 17. So square root of 17, 2 times 7 is 14, plus 3, 17. Square root of 17 does equal square root of 17. That's nice. So this is a case we don't have an extraneous solution. X equals 7, it works, we're right. Okay, let's try a couple more though. Okay, this one. Solve x equals the square root of x plus 12. All right, this is tricky again. We got x's on both sides, but luckily this radical on the right is already alone, so I'm going to go ahead and start by squaring both sides. And I got x squared equals x plus 12. All right, I hope you automatically notice this has an x squared and it is no longer, or it's not a linear equation. It's a quadratic equation, so we're going to have to come up with one of our strategies for solving quadratics. So definitely you want to set one side equal to 0 first. So if this was me, I would subtract x and 12 from both sides and get the right to 0 because I prefer to keep my x squared positive. So I've got x squared minus x minus 12 equals 0. Okay, and I got to think, do I want to use the quadratic formula, factoring, graphing? What do I want? I think this looks easy to factor, so I'm personally going to factor it. Okay, so to get x squared minus x minus 12, it looks like you can do x minus 4 times x plus 3 equals 0. If that equals 0, I think x equals 4 or x equals negative 3. Okay, so now is where I'm going to come in and check my solutions. So I'm going to check for 4. Does 4 equal the square root of 4 plus 12? Well, the square root of 4 plus 12, that's the square root of 16, is 4. So yes, that seems to check. If I try the next one, I've got negative 3 is what I'm plugging in. So I have negative 3 equals the square root of negative 3 plus 12. Negative 3 plus 12 is 9, so square root of 9 is 3, but I said it was negative 3. These are not equal, so this is an extraneous solution. So my only answer that I'm actually going to use is x equals 4, and I would say negative 3 is extraneous. Okay, so sometimes you get one answer that works, one that doesn't. Sometimes none work. You just got to be cautious and checking it's really smart. Okay, let's look at one more here. Solve the square root of 3x plus 8 equals 2. So solving this, again, my radical's not alone yet this time. So I'm going to subtract 8 from both sides first. Then I get square root of 3x equals negative 6. If you notice something right now, you could stop. But if not, let's just work it all the way through and see what happens. Okay, so this is alone now. I'm going to square both sides. Square root of 3x squared is just 3x. Negative 6 squared is 36. Okay. If I divide both sides by 3 right here, I'm going to get x equals 12. Okay, so now what I'm going to do, I'm going to go ahead and plug that back in, so for checking it. So square root of 3 times 12 plus 8 equals 2. I want to see if that's true. So 3 times 12, that's 36. The square root of 36 is 6. 6 plus 8 is 14, but I wanted it to equal 2. That did not work out. So in this case, we actually have no solution. Okay, and if you were one of the kids that noticed this right away, when I said square root of 3x equals negative 6, remember this sign, it just means positive square root, so it's not going to ever equal a negative number. So right here, you might have stopped and said there was no solution. But if you kept going, totally okay. Once you check it, you would still see there's no solution. Okay, to wrap it up, I want you to make sure that you can identify what is a radical equation, and then how can you figure out if something is an extraneous solution. Okay, if you know how to do those two things, and obviously are good at solving them, then you're going to be good to go.